Okay, so in this problem, we've got an observer here at the railway station, and we've got a train approaching the observer with some whistle on it. And at some time, let's call it t1, it's approaching the observer with some velocity v, let's call it v subscript t, standing for the velocity of the train. Now, a little time later, the train has moved closer to the observer. It's still travelling with the same speed, vt, and this is now at time 2. And we're asked to compare, well, how does the intensity and the frequency of the signal observed by the observer change at these two times? Well, intensity, that's another way about asking about the loudness of the sound. A loud sound is more intense. As the train gets closer, it gets louder. Sound, when it's travelling in 3 dimensions, actually falls off as an inverse square relationship. So it's louder here. So louder here. So it's going to get louder as it gets closer. Now, the tricky part is what happens to the frequency. Well, the frequency observed at t1 is given by the frequency emitted, so let's call that ft, the frequency of the train, and this is the frequency observed, and then it's going to be v. Now the observer's not moving, so we've got no observer velocity here over v, and now the train is approaching the observer, so the source is approaching the observer, so we put minus vt, that's the source's speed there. And at this later time, t2, we've still got the frequency of the train remains the same. There is still no velocity of the observer. And because the velocity of the train hasn't changed, we've still got minus the velocity of the train here for the velocity of the source. So these two frequencies have not changed. So the frequency remains the same. Now notice that the frequency only remains the same because we're comparing between this frequency and this frequency. That's what the question asked us to do. It didn't ask us to compare the observed frequency with the actual frequency emitted by the train. When the train is at rest at the station, the observer here will hear some frequency ft, the frequency of the train, the frequency coming from the whistle. And this ft is going to be less than the frequency that the person hears coming from the whistle as the train approaches that station.